Hello everyone, greetings of the day. I hope you all are doing well and are excited to learn some amazing technologies today. We will start in 2 minutes. Meanwhile, if you have got any questions or doubts from the previous session, you can let me know in the Telegram group. I will be helping you revise the concepts of default route and DHCP relay as someone has requested that. Anything else you want me to speak about today? I mean, those topics are something we are obviously going to speak in the coming sessions. Anything from the previously discussed topics or any doubts that you might have? All right. I'm sharing my screen to address your doubts and concerns. My screen must be visible, so I'll address your questions one by one. The very first thing we are revising today is the concepts of default routing. Just a second. Yep. So I'm giving you a quick revision to what we have discussed so far. Under the routing protocols, we spoke about two types of routing protocols, static routing and dynamic routing. Static routing was the method where we are adding routes statically. For example, if R1 is there connected to R2 and connected to a subnet, let's say 210.1.0/24. So this indirectly connected subnet will be installed on R1 using static route. When you do that manual installation of routes on a router, that's called static routing. Then yesterday we spoke about if we have a topology looking like this. One second. So we also spoke about this topology where if we have a situation like this where R2 and R3 have the only exit point as R1. So we can implement something called as default routing here, specifying the only exit point for all the indirectly connected networks. How do we install the default route? We say IP route 0.0.0.0, specifying that it can be any network, and then 0000, specifying that it can be any subnet mask, and then the next hop address, which is going to be in this case R1's IP, right? That's how we install default route. Yes, Michael, I'll share it after the session today. Don't worry. Just a minute, guys. I'm getting a call. Yeah, that's how the default routes are installed. Now the questions are about your DHCP relay configurations. So DHCP relay configurations is required when all your DHCP pools are on one dedicated server. If we have all of the pools created on one server, then that server would be responsible for providing IP addresses to these connected routers. Let's say for the network 210.1.0 and 210.2.0, I define my DHCP configs on R1 only and make it my DHCP server. Then in that case, I'll have to configure IP helper address on R2 and R3 so that these guys can take help from router 1 when DHCP is something that is supposed to be used. Is that clear? Anuj, try to rejoin the session. Now, the assignment that I gave you yesterday had four routers, R1, R2, R3, and R4. And each router is connected to one subnet, right? Now I told you guys to configure these networks and use the routing protocol RIP to make them all communicate with each other, right? To make them all communicate with each other. But I didn't tell you guys to, or I didn't specify where you are supposed to configure your DHCP pools, right? So what you can do in such a situation is you can configure them individually on all the routers respectively, right? For R1's network, you can configure DHCP pool on R1. Similarly, for the R2's subnet, you can put it on R2 and then so on R3 and R4 as well. So that's totally fine if you are using it or if you are configuring it on the routers individually and separately. No worries. Now you can simply work with it and maybe experiment with it using DHCP relay if you want to practice or revise that concept. Perfect. Any other questions or doubts before we proceed to the new topic EIGRP today? Okay, we have a question. If you want to configure DHCP relay, then which router to make the server? There is no such specification here. You can make it on any of the available routers. It's your choice completely. As we are in a virtual environment, we don't have any restrictions. But if we are an organization, then obviously there will be a design, there will be some strategies which you would be following, and according to that only you will construct your DHCP server. All right, moving ahead. Now the new topic for today is EIGRP. So let's understand what is EIGRP and how it works. EIGRP stands for Enhanced Interior Gateway Routing Protocol. Now again, a quick heads up that in the official content of CCNA, which is offered by Cisco, if you will check the section of IP connectivity, EIGRP is not a topic that is discussed. Okay. But when we speak about production environment, this is an important topic. You might find this protocol being used in your organization. Okay. Or we can say it is pretty important in terms of getting a good job, as interviewer is not going to just judge you on your CCNA knowledge as per the official Cisco's syllabus, right? They'll ask you some questions, some scenarios from anything which is network fundamentals or can be useful in production environment. So the only and only reason of discussing EIGRP for you all is to make you all better prepared for the industry. It's not a part of content officially. So if you will go for your CCNA exam, you might find no questions or maybe one or two questions related to EIGRP. I'm not sure if there is even a single pointer related to EIGRP in the official content, but as far as I remember, there is no EIGRP discussion in the official syllabus. So you won't face any questions or doubts. I mean, you'll not face any questions or scenarios in the official CCNA exam. But yeah, understanding, learning it is pretty important. So let's go. Let's understand this. EIGRP stands for Enhanced Interior Gateway Routing Protocol. And some of the characteristics of EIGRP are: the very first thing is that it is advanced distance vector protocol. When we talk about RIP is called as distance vector protocol. I missed on mentioning it yesterday in the notes. I'll put it now. It is called distance vector protocol. That means it is a protocol that considers distance for finding the best path. Similarly, when we talk about OSPF, we call it link state protocol, as it considers the link speed for finding the best path. But EIGRP is a combination of both of them. It's a mix of distance vector protocol and link state protocol, as it considers both bandwidth as well as distance to calculate the best path. That's why we call it advanced distance vector protocol. Yesterday, I gave you a question that if R1 is there, connected to R2, connected to R3, and then R5. And then there is another path via R4 like this. The bandwidth here is 100, 100 and 100 Mbps. On the other link, it is 10 and 10. As per rep, we understood that this will be my best path because it has lesser number of hops. But that was as per rep. Now, when we are talking about EIGRP, EIGRP is also going to consider the speed or the bandwidth which my link is offering. So according to EIGRP now, if I try to find out which is going to be the best path, it's going to be this one probably. Why? Because it offers a better bandwidth and can help me reach the destination earlier as compared to the other possible way. So what exactly is considered while metric calculation is something we'll discuss later on. As of now, just understand that it is called advanced distance vector protocol because it not just considers the distance, but also the bandwidth which the link is offering. Then this one is also a classless protocol like rep version 2. Classless protocol means that it shares the information of subnet mask with the network advertisements. Okay, what was the maximum number of hops that we could connect under rep? We discussed it yesterday. 15, right? With EIGRP, the maximum hops is 255. By default, this limit is 100, but it can be extended up to 255. Then AD value for EIGRP is 90. What was the AD value for rep routes? 120, right? Yesterday we learned that for rep, the AD was 120. Now for EIGRP, it is 90. So tell me if these routers are configured with EIGRP as well as the rep. So which protocol will they prefer for learning the best routes? They'll prefer EIGRP. Why? Because obviously EIGRP has got a lower AD. So the information provided by EIGRP would be preferred more. Then EIGRP uses 224.0.0.10 to forward updates. That's the multicast address used by EIGRP. Yes, Sayed. Then we say that EIGRP has some timers also, in which we have got a hello timer and the hold down timer. Hello timer is of 5 seconds and hold down time is of 15 seconds. So if two routers are connected, R1 and R2, after every 5 seconds, they will exchange hello messages. These hello messages are used for building the neighborship and then keeping the neighborship active. If I have sent hello message and my neighbor hasn't sent any hello message, then I'll wait for how long? I'll wait for 15 seconds for my neighbor before considering the neighbor as dead. After 15 seconds, I'll consider my neighbor as down and I will remove all the information related to it. That's how fast it is. In the case of rep, we had so long timers. I mean, although it might sound very less, that 240 seconds or 180 seconds is not a long time. But guys, in production environments, it is definitely a long time. Imagine you are working on something or you are on a conference and there is a lag or there is a disconnectivity for 3 to 4 minutes. So it's a long enough time to mess up things in production environment. But EIGRP comparatively is pretty fast. It takes the decision very quickly, tries to look for some alternative, and basically removes the information after completion of 15 seconds. Nancy, like after 15 seconds, it's simply gonna remove it. So no additional timer, no further waiting. It's just waits for 15 seconds. If we receive no updates, we disconnect, we consider the neighborship as down and remove the information from the tables. Then EIGRP requires certain values to match before two routers can become EIGRP neighbors. So there are some EIGRP neighborship parameters, which includes the first thing as routers should be in same subnet. Second thing is routers should have same autonomous system number. As of now, just understand that autonomous system number is a group number. So the group number of two routers should match before you can make them neighbor, right? And obviously they should be participating in the same subnet. That means their network on which they are connecting should be same. Then finally, the third thing is they should have same K values. K values are used for calculating metric. Later on, we are going to speak about it. As of now, just understand that these are the requirements for building EIGRP neighborship between two devices. After the EIGRP neighborship is established, EIGRP maintains certain tables also. Let's talk about what are the EIGRP tables. EIGRP maintains three tables. The first table is neighbor table, in which, as you might be able to guess, the information about neighbors are added. So inside the neighbor table, once the parameters match, the information about connected device is added. Second table is topology table. Topology table contains all the routes received all the routes received from neighbors. Then out of all the routes which are received from neighbors, the best routes are installed inside routing table. Out of the routes received from neighbors. The best routes will be installed in routing table. No, it's not RCC. Actually, I wrote it received, like I was giving it a short form. Yeah, so these are the three tables which are maintained by EIGRP. Which are maintained by EIGRP. Okay. Now to check neighbor table, and obviously we can check it after EIGRP is configured. To check the neighbor table, the command is show IP EIGRP neighbors. Similarly, to check topology table, the command is show IP EIGRP topology. And to check routing table, you guys tell me what is the command. To check routing table, what command do we use? Show IP route. Not show IP EIGRP route. The command is going to be just show IP route. The routing table is going to be common always for all the protocols. So show IP route is the command which we'll be using for checking the routing table. Now we'll do a small lab to understand what we have learned so far about the characteristics, where I'll create a small topology R1 connected to R2, a switch with some end devices, another switch with some end devices, and we'll try to connect them with EIGRP. Now, when I connect them with EIGRP, I told you I have to put them on a group number, right? I have to use a group number. So I'll be using EIGRP 10. That 10 in technical terminology is ASN, which is autonomous system number. Clear? So let's configure this small scenario and then we will speak about a little more regarding the metric calculation and the regarding the metric calculation and the algorithm which is used by EIGRP. So I'm sharing my packet tracer window and let's get started with the practical part. When we'll discuss about the metric calculation and EIGRP's algorithm, which is dual algorithm, at that time I'll address your question, Mudassir, regarding the AD and FD. Okay. I hope my packet tracer window is now visible. So I'll configure a topology like I mentioned, R1, R2, couple of switches, some end devices, and then let's make the cable connections. I have a quick question for you. I want to use 192.168.1.0/24 network. I want to break it down into two parts so that one part could be used for this subnet and one could be used for this subnet. Let me know what section can be used for my first subnet and what can be used for the second set of devices. No, Michael, it shouldn't be /30. My question that I have for you all is I want to break a /24 network into two parts. A /24 is of how many addresses? 256, right? So I want to break it down into two parts. That means I want two networks of 128 addresses. So what range with what subnet mask should I use? It's not /28, guys. It's going to be /25. Why are you guys rushing out so much just to put a response in the group? You can take your time, do the calculation. Instead of trying to answer quickly, try to answer correctly, right? Our goal is to get the correct answer. It will be /25, correct? So I can say this section can be 192.168 1.0/25 and the other section will be 192.168 1.128/25. Correct? This is how I can break down my complete network into two parts. Moving ahead, between the routers, I will use 12.10.1.0/30. Let's begin the IP configs and we'll also create DHCP pool for both the networks. So I'll get started from my first router. I'll rename it first of all as R1 and this one as R2. Let's go to router 1, CLI. I'll say no to the question. Enable config T, host name R1, FA0/0, IP address 192.168.1.1, 255.255.255.128, no shutdown, exit. Then interface FA0/1, IP address 12.10.1.1. What should be the subnet mask for /30? Two five five 255.252. No shutdown, exit. Then I need to create a DHCP pool for my LAN network. So I will say IP DHCP pool A for my network 192.168.1.0 with the subnet mask as 255.255.255.128 and the gateway router or the default router IP as 192.168.1.1. Clear, guys? Then let's jump on to the router number 2 and configure IP and DHCP configs. This is my router 2. I'll go to the CLI, say no to the question, enable config T, host name R2, FA0/0 IP address 12.10.1.1, sorry, 12.10.1.2, 255.255.255.252, no shut, exit, FA0/1 IP address 192.168.129 because 128 will be my network ID and then 255.255.255.128. No shut, exit, IP DHCP pool A for the network 192.168.1.128 255.255.255.128 with the default router address as 1.129. Let me know if you have got any questions. All right. Let's go and provide IP address to these end devices. Desktop IP DHCP. We got the IP 1.2, got the subnet mask correctly, got the gateway IP correctly. PC1, desktop IP DHCP. IP is 1.3, subnet mask is /25, gateway is 1.1. Guys, just like 1.0 is the network ID and 1.1 is the first usable IP, similarly 1.128 is the network ID and 1.129 will be the first usable IP. So that's why on my router 2, we have given the IP as 1.129. Clear? Then I'll go to my end devices and will put IP configs on them. We got the IP as 130 and then my final PC DHCP 131. Now it's time to connect these over EIGRP. So like I said, I'll create EIGRP autonomous system number 10 for these devices. They'll participate in EIGRP AS10. Their subnet is same. And by default, their K values are also going to be same, which we haven't yet spoken about. But yeah, their K values will also be same by default. So can I say I am meeting all the three criterias? What were the three criterias? Same subnet, same autonomous system number, and same K values. So we are meeting all the three. So that means EIGRP neighborship will come up. Like I have said earlier, K value is something which is used in metric calculation. We are yet to discuss that. Am I not audible clearly, guys? Please confirm. On switch, we don't require any configuration. It's not going to participate in layer 3 communication. It will simply forward traffic from my PCs to the router. Shall we proceed and look how the EIGRP can be configured? All right. I will go on my router number 1. Now, before we speak about configuring EIGRP, there is something called as wildcard mask, which we have to understand. Subnet mask represents the network bits as 1 and the host bits as 0. If I talk about opposite, then that's the wildcard mask. Wildcard mask is inverse of subnet mask. In the wildcard mask, the network bits are represented with 0 and the host bits are represented with 1. So simply, if you do inverse of your subnet mask, you get your wildcard mask. For example, for class A, what is the default subnet mask? 255.0.0.0, correct? If I talk about wildcard mask, it's going to be 0.255.255.255. An easy method to calculate wildcard mask is subtracting your subnet mask from 255.255.255.255. If you will subtract anything from this, you will get your wildcard mask. For example, I'll try to find out the wildcard mask for class C. So what I'll do is I'll subtract my class C's subnet mask, which is 255.255.255.0. And what do I get? I'll get 0.0.0.255. That's going to be my wildcard mask for class C. Make sense? Similarly, for my this network here, the subnet mask is 255.255.255.128. That's my subnet mask. So what will be the wildcard mask? Let's subtract this from 255.255.255.255. I'll say I want to subtract 255.255.255.128, and I will get 0.0.0.127. So I can say for this network, my wildcard mask is going to be 0.0.0.127. Make sense? Similarly, for the other network also, my subnet mask is 255.255.255.128, and my wildcard mask will be 0.0.0.127. Let me know what will be the wildcard mask for this network, which is /30. As the subnet mask is 255.255.255.252, the wildcard mask is going to be 0.0.0.3. Clear? Keeping that logic in mind, let's get on to the router number 1 and let's try configuring EIGRP on it. The commands are very simple and easy. I'll say router EIGRP and then I have to specify autonomous system number. It can be anything between this range. We are assuming that we'll take it as 10. So I'll say EIGRP 10. Then I'll add my directly connected networks saying network 192.168.1.0. But along with that, I will accompany the wildcard mask here, which is 000.127 for my first network. Similarly, network 12.10.1.0 with a wildcard mask as 0003. That's all. Exit. I'll go to router 2. Router EIGRP 10, network 192.168.1.128 with the wildcard mask 000.127 and network 12.10.1.0 The moment I hit the enter button, we can see EIGRP neighborship is up. That means they must have exchanged the routes automatically by now. And if I go and check my routing table, show IP route, I can see an EIGRP route is added for the network 192.168.1.128/25. EIGRP routes are represented with letter D, as you can see here. Okay. Then AD value is 90 and the metric calculated is 30,720. It is reachable via 12.10.1.2. This has been the time for which the route has been installed in the routing table. Exit interface is FA01. What is exit interface? From where the packet will take exit to reach this destination. Similarly, on router 2 also, I can check my routing table, show IP route, and we can see we have got an EIGRP route for 1.0 having AD as 90, 30,720 is the metric, reachable via 12.10.1.1. It's been 1 minute 7 seconds for how long we have learned the route. Exit interface is FA00. Then finally, it's time to check connectivity between PC0 and PC2 and 3. I'll go to PC0, I'll ping 192.168.1.130, which is my PC2. And we can see we are getting the replies. That means we have successfully connected two different networks together. Questions or doubts? Calculate the wildcard mask. You just have to subtract subnet mask from 255.255.255. Whatever is your subnet mask, minus that from 255.255.255, and you will get your wildcard mask. Any other questions or doubts? Parvez, what subnet? I didn't get your question. You're talking about subnet mask? No, Michael, here we are in a small virtual scenario. We are using a simulator, so it doesn't matter how much AS number you are taking or how you are designing your topology. But in productions, it is always going to be designed first, and you are provided with that information to configure the protocol. How much address we are using in this topology. We are taking it randomly per ways. Like I have said earlier, this is a packet tracer scenario simulator which we are using for practicing. We are taking it randomly. We have broken down a big /24 network into two parts, where the first part is here and the second part is here. So yeah, we are doing it randomly, but in productions, it is already designed and defined, so you will get those details and you have to configure devices according to that information only. That's a responsibility of an network architect, and that's something requires a great amount of knowledge and understanding of the protocols, because you would be designing the whole topology, whole network. So it's your responsibility to dedicate the subnets, your responsibility to plan everything, to ensure there is high availability, the network is secure, everything is your responsibility. So yeah, as you grow in your career, you reach that particular level where you take up the charge of defining how an organization network will look like. I'm sharing the lab guide for EIGRP, guys. Take your time to practice this, and then we will move ahead. I'll be right back in 10 to 15 minutes. Meanwhile, you guys can practice this configuration for which the lab guide I have shared. And once you're done, we'll move ahead to the next one. Okay, we have some questions here to address. What benefits of wildcard mask and EIGRP? Um, so when we specify the wildcard mask, we basically try to tell EIGRP which network or which interface they are supposed to make a member of EIGRP configs. So actually, when I'm saying 192.168.1.0, 127 under EIGRP configs, I'm telling router to find out the interface which is inside this network and make it a part of EIGRP configs, which is going to be basically FS00. So that's a required syntax that we specify for telling the router which interface is supposed to participate in EIGRP. Then we have a question, what is no auto summary? So in the certain examples of EIGRP configuration, also in the lab guide of EIGRP configuration, there is a command no auto summary. What happens? EIGRP used to automatically summarize networks back in time with the previous iOS versions. iOS is the operating system of router. So earlier at that time, EIGRP used to automatically summarize routes. What does it mean? It means if there are 5 small networks, then it would combine them into one and tell it as a summary route. So we disable that feature by writing no auto summary. But in the newer iOS versions, this additional command is not required because in newer iOS versions, EIGRP will not automatically summarize any network. Then there is no wildcard mask configuration in the lab guide. The reason behind that is because we are using default network subnets. If my class C network is there and a /24 subnet mask is there, putting the wildcard mask is not mandatory because it will understand it automatically. So if you are using default subnet masks, you don't require the wildcard mask. Okay. Any other questions or doubts regarding the EIGRP configs? So the previous iOS version used to automatically summarize the routes. Summarizing means that, for example, in this case, I have 1.0/25. Then there is 1.128/25. So when they would have been connected to the same router, for example, R1 is connected to both the routers, let's say both the networks, 1.0/25 and 1.128/25. What EIGRP used to do was it used to combine them together into one advertisement. It would automatically summarize them into one big network instead of two smaller parts. So to disable that auto summarization feature, we have the command no auto summary.
Yeah, sure. Because we are using the default subnet mask. For example, if I'm using class C network, so what is the default subnet mask for it? 255.255.255.0, right? If you are using the default subnet mask, you need not to specify it. It will be understood by the router automatically. That's why you don't need to mention it. But if you are using something else, like in this example, we are using /25 /30. So it becomes mandatory to add the wildcard mask information. Okay, guys, 5 more minutes. Try to complete this quickly, and then we shall move ahead towards the discussion of metric calculation and dual algorithm. Okay, we have a question. What other courses do I teach? So I teach CCNA, I teach CCNP, NCore, NRC, I teach SD-WAN, SDA. I deliver batches for CCIE and CCNA DevNet, which is for network automation. That's something I do deliver trainings for. So yeah, we can say all the enterprise infrastructure related trainings and automation. Okay, try to wrap it up. After 5 minutes, we'll continue with the further discussions. So we have another question. Is there any uh, difference between paid and free CCNA training delivered by me? No difference, guys. Whatever you are receiving here for free is also what you get for the paid CCNA. It's just that paid CCNA gives you the ability of unmuting yourself, discussing your questions. You get my support even after the completion of training. You can discuss your queries with me anytime. Yeah, so you get a special attention, definitely. And you are made a member of special group where only your batchmates are there. So you can discuss your projects, your assignments, all of those things. That's great, Tarun. Congratulations. That's amazing. So guys, we have Tarun who has passed CCNA. So let's congratulate him and let's hope that all of us who are looking forward to get this certification can uh, proceed to our goals and get this amazing thing with us. I laid back. Allow me at least a few minutes to go through the chat. You see, there are so many messages, so I take a little time to read them. Definitely, I can explain how to calculate wildcard mask. So all you need to do is you need to subtract your subnet mask from 255.255.255 and you get your wildcard mask. For example, here the subnet mask was 255.255.128. We subtracted it and we got the wildcard mask 0.0.0.127. Sure, Michael, that's a great suggestion. But the problem is that sometimes when you do after the session, maybe you get the technology well, so you can, you know, do the lab even after the session, but sometimes participants face issues. So I prefer giving them 10 minutes or 15 minutes to try the lab quickly so that they know that they have got the concept. All right, let's get back to the topic. I'm hoping that everyone must have completed this. Let's understand now how the metric calculation goes and what exactly is the algorithm used by EIGRP. I'm sharing my other screen. And it should be visible now. All right. Now we are going to understand first of all what is the metric calculation formula for EIGRP, and we'll also be speaking about an algorithm which is used by EIGRP to find out the best path, which is your dual algorithm. So first of all, before we get on to understanding what is the metric calculation formula, I want to tell you all that no one of you will be questioned about writing this formula or calculating metric manually by yourself. Okay, this is just being discussed for our own understanding. You just need to understand it, nothing else. For metric calculation of EIGRP, there are two types of values which are considered. Some variables and some constant values. When we talk about the constant values, we take K1, K2, K3, K4, and K5. By default, the value for K1 and K3 is considered as 1, and the remaining is considered as 0. Along with that, it also considers bandwidth, load, delay, maximum transmission unit, MTU, and reliability. Bandwidth is the rate on which packets are transmitted on a particular link. Like we say 100 Mbps, 10 Mbps. This is the bandwidth that we are talking about. Okay. Then load is how capable the link is to carry some load of traffic. This represents the current utilization of the interface. Delay is the delay which a particular packet is going to take to cross all the interfaces in the path. So the amount of time which it takes to cross these interfaces or get through the interfaces is what we consider delay as. Then MTU is the maximum transmission unit, where basically we specify what maximum size of packet can be transmitted over a given uh, interface. And lastly, reliability is how reliable that interface is if I want to send some traffic over it. Make sense? All these values are used together in EIGRP metric calculation. There is a big formula which we use for calculating metric. What is this formula? We say 256 multiplied by K1 multiplied by bandwidth plus K2 multiplied by bandwidth divided by 256 minus load plus K3 multiplied by delay then the whole thing is further multiplied by K5 K5 divided by reliability plus K4. This is the complete formula which we use for calculating metric in EIGRP. Now, the last part of this formula is considered as 1. So that means we are just left with 256 multiplied by K1 multiplied by bandwidth plus K2 multiplied by bandwidth divided by 256 minus load plus K3 multiplied by delay. And as the last part is 1, so we are not going to write that again. Then after that, we said that the value for K1 and K3 by default is 1 and the remaining is 0. So let's put these values. 256 multiplied by 1 into bandwidth plus K2 is 0. So 0 divided by 256 minus load will make it all 0. Plus K3 is again 1. So 1 multiplied by delay. What are we actually left with? 256 multiplied by bandwidth plus delay. So there will be an interview question that what values by default create an impact on EIGRP metric calculation. So now you know it is bandwidth and delay. When you multiply bandwidth and delays sum by 256, you you get your EIGRP metric. Clear, guys? The K values are not fixed. These are the default values. These can be modified also. But by default, if you make no modification or changes, it will be considered like this. Now, I have a question. If let's say R1 is there and we have R2 and we have R3 and we have R4. Okay. The bandwidth here is 100 Mbps, here it is 10 Mbps, and here it is, let's say, 100 Mbps, 10 Mbps, and 100 kbps. So when I calculate my metric to reach R4 from R1, should I consider 100 Mbps, 10 Mbps, or 100 kbps? Which one? So in the metric calculation, always remember the bandwidth that we consider will be 10 raised to the power 7 divided by lowest link bandwidth in kbps. So basically, in this example, it will be 100 kbps as that's the lowest link band. Make sense? Then similarly, when we talk about using delay is basically cumulative delay, which we consider in metric calculation, which is sum of all delays. I'll explain you what it means. To move from R1 to R4, there are multiple exit interfaces which will have some delay. So assume that the delay for the exit interface of R1 is 200 Here it is again 200. Here it is again 200. And let's say R4 is connected to some network for which again the interface has a delay of 200. So when I will calculate metric in EIGRP, I will add all these delays together, making it 200 plus 200 plus 200 plus 200. And will also divide it by 10 as the delays are configured in tens of microseconds. So to convert it into appropriate, we can say appropriate terms, we need to divide it by 10. So when we talk about bandwidth, we say 10 raised to the power 7 divided by the lowest link bandwidth. Whatever bandwidth would be lowest, you will consider that. And when we talk about delay, we say we add all the delays of all exit interfaces and add them and then divide them by 10 to make it in microseconds. Because when we configure a delay, it gets configured in tens of microseconds. Now we have some questions. We need to convert always into kbps. We need not to calculate metric anytime, any day. It is just for our understanding. You are never supposed to calculate metric. You don't have to plus minus anything here. It is just understanding that you have to take. But for the understanding also, do we need to use bandwidth in kbps only? Yes. In the metric calculation formula, when we are talking about bandwidth, bandwidth will be represented like this. So we can say actually this is 256 multiplied by 10 raised to the power 7 lowest bandwidth plus for delay we can say sum of all delays. This is the actual formula. Is that clear to all of us? So now if you get a question, what are the two default values which are considered in metric calculation of EIGRP, you can tell it is bandwidth and delay. And if they question more, how is bandwidth considered? We will define that it is considered as 10 raised to the power 7 divided by the lowest link bandwidth. This 10 raised to the power 7 is your reference bandwidth. Then similarly, if they ask how delay is used, it is considered as sum of all the exit interface delays. Clear? Now I will show you. Yeah, I'll write it here, no worries. Sum of all delays divided by 10. Now I will show you the same on my packet tracer. And let's try to see how the metric is being calculated in my topology. You must be able to see my packet tracer window now, right? First of all, what is the lowest bandwidth here? Here I only have one link, which is fast Ethernet link. Fast Ethernet link offer bandwidth of 100 Mbps. So it's a 100 Mbps link. And that is the only lowest link which I have, right? Then let me find out delay of all exit interfaces. I'm trying to figure out what is the cost to move from R1 to this network. How many exit interfaces are there? We can say one exit is here from R1, right? So FA0/1 is my first exit interface. I'm not able to draw, but yeah, FA01 is my first exit interface. Then it reaches R2 and from R2 it takes again exit via FA0/1. Correct? This is my second exit interface. So while calculating the delay, I have to check delay of this interface and this interface. So let's go. Let's see how do we check that. enable show interface FA0/1 pipe include delay. Okay, I'll say include delay in small. Okay, never mind. I'll just remove this and say show interface FA0/1. When I do so, okay, it is written in short form DLY. We can see the delay which is being considered here is what? We have it as 100, right? But like I defined earlier, it is configured in tens of microsecond. So we will take it as 100 divided by 10. Similarly, let's find out the delay of another exit interface which we have FA0/1. Show interface FA0/1. Here also the delay is 100. Keeping that logic in mind, here I have 100 as the delay. Here I have 100 as the delay. So I can say my metric is equals to so if I calculate about the metric of this network, it's going to be 256 multiplied by bandwidth plus delay. For bandwidth, I can say 10 raised to the power 7 will be divided by 100 Mbps converted into kbps. So to convert mbps into kbps, you have to multiply it by 1000. So 100 multiplied by 1000 will give me 100 and 3 more zeros. Do you agree? Perfect. Delay is going to be 200 divided by 10. Do you agree? Perfect. So 10 raised to the power 7 means 10, 1 and 7 zeros. So 1, 2, 3, 4, 5, 6, 7. Can someone do this division and tell me what will be the result of 1, 7 zeros divided by 1 and 5 zeros? It's going to be 100, right? So I can say my metric will be 256 multiplied by 100 or bandwidth plus 20 for the delay. We have a question, how are we calculating delay? 100 is for this interface, right? 100 is for this interface. And we said we have to divide it by 10. So 200 divided by 10, 20. Make sense? Now please calculate 256 multiplied by 120 on your calculator and let me know what is the result of that. Three zero seven two zero. And if I check my routing table, what is my cost? 30720. So now you have learned how this cost is coming out, right? Although, like I explained or mentioned earlier, no one will ask you to calculate the metric or do all these calculations. It is just for our own understanding. But yeah, Now you understand how this value is coming out and how this 30720 was calculated. Let me know what questions or doubts do we have in this. Hari Vijay, when we talk about bandwidth, 1 MB is equals to 1000 kbps. 1024 is considered in the case of storage. That's why when we are talking about bandwidth, we'll take it as 1000 only. The conversion which we consider for calculating storage is where you use 1024. So we have a question: in order to become neighbor, two routers should have same K values. Which router's K value did we calculate in the previous example? We are talking about the cost from R1 to this particular network. So we will consider K values of R1. But by default, they are same on both the sides. So the calculation will bring you the same results. But if you are calculating from the POV of R1, you will consider K values of R1. All right, the final discussion about EIGRP is regarding the algorithm which is used by EIGRP called dual algorithm, diffusing update algorithm, which we will discuss in 5 minutes. For 5 minutes, I'm sharing my other screen. Try to revise what we just have discussed, and then we shall move ahead with the dual algorithm discussion. So here we'll be speaking about dual algorithm in 5 minutes. Meanwhile, you can understand and revise the formula. All right, I hope everyone must have revised this by now. Let's continue and understand the dual algorithm. The dual algorithm is something which is used by EIGRP to find out the best routes. Dual stands for diffusing update algorithm. Diffusing updates algorithm. According to dual algorithm, there are four values or four terms that we have to understand. First is feasible distance. which is total cost from source to destination. Then we have a reported distance, which is also known as advertised distance. Which is total cost from neighbor to destination. Then we have successor, which is the best path to destination. And we have feasible successor, which is second best path to destination. Assume that you have router number 1 connected to router number 2 connected to router number 3. The cost to move from R1 to R2 is 10 and to move from R2 to R3 is 20. What do you think? What will be the feasible distance here for R1 to reach R3? Feasible distance, as we have defined, is the total cost from source to destination. So 10 plus 20, feasible distance is gonna be 30. What will be the reported distance? Cost from neighbor to destination. So neighbor to destination, which is 20. Then whatever is the best path, that will be considered as successor. And if you have a second best path to reach the destination, that will be your feasible successor. For example, again, R1 is connected to R2, R3, R4, and all are connected to R5. The cost is 10, 10, 12, 12, 15, 15. I can say I have got 3 routes, R1 to R2 to R5, then R1 to R3 to R5, then R1 to R4 to R5. What will be the feasible distance for the first route, guys? Total cost from source to destination. It's going to be 20, right? For second one, 24. For the third one, 30. Correct? Similarly, let me know what will be the reported distances. 10, 12, 15. Now, the path having lowest FD will be considered as successor. Clear? So this is my best path. I will consider as successor. This is my successor. Which one is second best path here? Can I say the second route? This is the second best path. Yes or no? So this will become feasible successor. But before we can define it as feasible successor, we have to make sure that it meets feasibility condition. What is feasibility condition? It says a route can become can become feasible successor only if the reported distance of that route is less than the feasible distance of current successor. So let's find out if this route meets the feasibility condition. Feasibility condition says a route can only become feasible successor if reported distance of that route is less than the feasible distance of current successor. A route can only become feasible successor if the reported distance of that route is less than feasible distance of current successor. Is it meeting the condition? Can I say 12 is less than 20? Yes or no? Yeah. So it's meeting the condition. That's why it's eligible to become feasible successor. And I can definitely say that this route of mine will be my second best route called feasible successor. Successor is added into the routing table and feasible successor is added into the topology table. When my successor route will go down, my feasible successor will become successor. It will change into successor and will be installed into the routing table. Are we clear about this? That's how the dual algorithm works. And yeah, that's all what we had to discuss today. If you had got any queries or doubts, let me know. Otherwise, we are good to wrap it up. Don't worry about the notes. I'll share them. Any questions? Any doubts? Thank you, Ashraf. Glad that you enjoyed the session. Your homework is just to practice what we have discussed, experiment with your EIGRP learnings, RIP learning, static route learning. Do practice everything. And then in the coming session, we'll speak about OSPF. Exactly, you got it right, Nicholas. When this route will become successor, we'll try to find out another second best route, which will become feasible successor. Guys, I'm sharing these notes, don't worry. Feasible successor is defined here, which is simply my second best route. Thank you guys. Thanks for the compliments. I'll share the notes with you all. Lab guide was already shared earlier. And that was all for today. I'll see you guys now on Monday. You have good amount of time to practice which whatever we have learned. Do practice all the things so that on Monday we can continue with a new topic. Take care. Bye bye. Enjoy your day.